Today we will discuss about conservation principle of momentum using Newton's third law. So here we consider two objects of masses ma and mb. They are moving with speed ua and ub in the same line in the same direction. If ua is greater than ub, then there will be collision, and in the figure it is shown that after collision their velocity has become va and vb respectively. Three cases are there. This part is before collision, at the time of collision, after collision. So we know that at the time of collision two forces will be applied. One will be force exerted by A on B, another one is force exerted by B on A. So FBA means the force exerted by B on A, FAB is the force exerted by A on B. Okay, so if one is the action, the other one will be the reaction. So according to Newton's third law, action and reaction are same and they are opposite also, so that is why there is a negative sign. Now FAB equals to FBA. So FAB means, as I told you that FAB is a force exerted by A on B, whose momentum will change? B's momentum will change, suppose. Okay, so if B's momentum changes, in that case we know that change in momentum, the formula is what? mv minus u by t, but here we will write mb vb minus ub divided by t, because B's momentum is changing. That is equal to, in right hand side, minus will remain as it is. FBA is the force exerted by B on A, so whose momentum is going to change? That is the A's, and that is why we will write here MA VA minus UA by T. Then T will get cancelled. Okay, once you open the bracket we get this equation, and then if you change the sides we get this equation. So here it is clear that this part is what? It is the total momentum before collision. You can see MAUA means it is the momentum of the first object before collision. MBVUB, momentum of the second object before collision. Once you add it, it gives us the total momentum before collision, which is equal to, and the second part, this part is the total momentum after collision. MAVA, it is the momentum of the first object after collision. MBVB, momentum of the second object after collision. If you add, it gives us the total momentum after collision. So we write total momentum before collision is equals to total momentum after collision, which is the conservation principle of momentum. Okay, then we'll solve one sum, but remember that whenever you do any proof or any kind of derivation, you write the description of the things that you are using. Means in this case you have to write it in this way. Let us consider two bodies of masses MA and MB. Their speed, initially their speed is UA and UB. Finally their speed after collision becomes VA and VB. At the time of collision, both are exerting force on each other. One force is FBA, which is the force on A by B, and FAB. So in that way you will write the things, okay, for all kind of derivation. Then for this sum, two objects of masses 100 gram and 200 gram moving in the same line in same direction collides, and their velocity before collision is 20 and 15 meter per second, okay, respectively. Now after collision both the objects sticks together and move with the velocity v. So once they are sticking together, their final velocity will be same after collision. So VA, this condition actually it is mentioned here, VA is equal to VB is equal to V, and we have to find out what is V. Okay, so for that certain things we'll note down, like the things which are given. The given things are MA and MB. So MA is 100 gram, we'll convert it to kg by dividing by 100, we get it 0.1 kg. MB 200 gram is 0.2 kg. UA is 20, UB is 15. VA, VB both are same as they are sticking together and moving, and which is equal to V. So we have to find out what is V. Okay, so to find V, what we can do is, okay, so just use this formula, this one, and substitute the values. MA we have already written 0.1, UA 20, MB 0.2, UB 15, This side VA and VB both are same, which is equal to V, so I have taken V common. What will remain? That is MA plus MB. Now you substitute the value of MA, MB, 0.1 and 0.2, so it becomes 0.3. This one 0.3. Okay, and V will remain as it is. In right hand side we get 2 plus 3 is 5, so finally V is equal to 5 by 0.3, which is equal to 16.67 nearly meter per second. So this is the velocity with which both the objects are moving after collision. Thank you.